Hello, good morning, everyone. Now we'll start our session number 4. We'll discuss today the chapter Sustainable Sites. Sustainable Sites. First, can you hear me clearly? Just right. Okay. Sustainable Site is a critical chapter. Always we confuse between sustainable sites and location and transportation. I don't know why, because both related to land use. But I think there are differences because location and transportation is the initial phase where you select the land, the location of the project, and the relation to its available transportation options. Whereas in here, we come to focus on the site area that has been selected and start to study the environmental options or environmental impacts and what are the options to improve our impact on the site and surroundings. Okay. So in sustainable sites category, it is a category. We call it sustainable site category, sustainable sites impact category, whatever you can call it. But at the end, it is a category. The first one is a prerequisite, pollution prevention during construction or construction activity pollution prevention. Very important to memorize the names of the prerequisite, especially prerequisites, and also the credits. Why? It will help you answer and locate the exam question where it is. It is in what category. So I need from you always to think where the question is, under what credit. This is the 80% of the answer of the question, to locate the right location of the question, where he asks you, many credits, many prerequisites, which one he asking you. Okay, so and we'll take one by one. The first two are prerequisites, which is site assessment and construction activity pollution prevention. Okay. In front of us, you can see two pictures, one for a site before development. One second. One before development and another one is showing the site after development. Okay. So here we can see what is the impact of our development on the site itself. These buildings was not there before. So, for example, what was the situation when, for the ecosystem, the trees, the water, and so on? So we find here, for example, when we have rainwater, it will infiltrate very easy through the natural land cover. More than 50% easily will infiltrate. But in here, of course, less than 50% will infiltrate or penetrate the land cover because it's asphalt or concrete. Hence, we will find that it's difficult here. Some problem issues like stormwater runoff here will be excessive, but here no, the natural land will manage the stormwater and so on. The heat here is higher. okay? But the heat here or the temperature is lower, okay? So from there, we can see how the impact. Here we call this impervious cover. Impervious means like asphalt and concrete. It will not absorb or water will not infiltrate through it. How we can measure it? More than 55%, more than 50% will just remain on the top of the asphalt. It means it is impervious. But this one we call it pervious. Pervious means it will infiltrate easily through the land cover. So we need to know here pervious and impervious and what are the impacts of development like what we see here based on the climate and natural and the land and surroundings and so on. The first is a prerequisite. We call it construction activity pollution prevention. Construction activity pollution prevention. So the intent here to reduce pollution on site during construction. So it's a construction prerequisite. We need to manage three elements. First is erosion, second is sedimentation, third is dust. And we'll see what is erosion, what is sedimentation, and what is dust. First, erosion is the loss of topsoil. Like what we can see now, especially in the areas where there are like some mountains, hills, and so on, the land is not flat. We find this is very exposed to something like erosion, especially when the rain comes, it will take this soil and run away from the site. In urban projects also within the city, erosion is a problem. Why? The dust come from site to the nearby buildings and cause many problems. This building already built, developed, the facade is very clean, and then you start to the dust to spread everywhere in the streets and so on, and causing also reduction or reduce the air quality. So erosion have many issues to the air, to the water, when the soil run with the water. This is the erosion. If you remember this photo, it's enough for you to know what is meaning of erosion. Every erosion is followed by sedimentation. What is sedimentation? We said the dust or the water takes the dust or the soil and run away. It can run away in the streets and so on, and it can run to the water bodies nearby. Like what we can see in the photo, the sediment, you can say sedimentation. So the sediment is running to the water body, causing many issues to the ecosystems within the water bodies. The living animals or fish or whatever, any ecosystem living within this body, it will be affected, of course, because this sediment include fertilizer, include chemicals, include oil, include many things, okay? In addition to the water body itself, the level of the water body. So the sedimentation definition is addition of solid particles in water bodies. The sediment, the issue that the sediment from construction sites rich in contaminates or contaminants and pollute the water bodies. It can cause also air pollution. Let's say it will dry or even dust without water running off. The air will take this soil and spread everywhere, causing the airborne dust generation. So erosion through water and air. Strategies is the most important part that come in the exam. We know what is erosion, what is sedimentation, what is the dust. This is the issue. What is the solution? This is the impact. What is the mitigation? Okay. So the mitigation here, or how to mitigate this issue, is through strategies. What are these strategies? Let's see. The project should develop and implement erosion and sedimentation control plan, or EC plan, which comply with APA 2012 construction general permit or local standard. So what is ESC? So the strategy here, develop ESC plan. When you have a sustainability consultant in your project, you will find he is telling you that we need to develop ESC plan. What is ESC? What is stand for? ESC, erosion and sedimentation control plan. Okay? Erosion and sedimentation control plan, which comply with APA 2012 construction general permit. This is the reference standard. When I develop a plan, I am not developed based on my own reference. I always find the standard. I look at this standard, how they deal with erosion and sedimentation and control. It's a standard or something like act like some, let's say code, and become act, become like government enforce it. So EPA, EPA refers to Environmental Protection Agency. That this organization in USA developed construction general permits requirements. One of these requirements, erosion and sedimentation control plan. So they develop it based on the standard, of course. So erosion and sedimentation control plan, this is the plan you do. The APA 2012 construction general permit or local standard is your reference. Your reference, where you will go there and see how you can develop your plan based on this. And this is very important. Okay? Clear? Any question here? Okay. So erosion and sedimentation control plan. What in the APA then? Let's see. What in the APA or what in the plan? Something like this, just examples in how to manage the erosion and sedimentation in your site or at your site. One of them is to do stockpiling. What is stockpiling? Every strategy is suitable for some area or some site types. Let's say an urban area, developed area, you see the buildings around the roads and so. So having dust here will impact all these surroundings. So what they do, they cover the area or they collect the dust and put some stones or some any organic cover to the land, and this dust or this soil that is covered will be used later, or they will move it to another location. So we call this stockpiling. Stockpiling. Okay? This is stockpiling. So topsoil removed from the site and piled in a safe place, replaced by free drain gravel. And finally, by the end of the project, it will be restored to the site location again. So there is no issue. Another strategy is stabilization using temporary seedings or permanent seedings. Temporary seedings or permanent. So some plants fast growing or grasses just for temporarily to stabilize the soil, or permanent, maybe you will plant the trees that will be part of the project landscape later, trees and shrubs. Okay, so based on the site condition and location and the availability of space, you will plan your stabilization strategy. Okay, clear? Can you hear me, guys? Okay. Another stabilization strategy, not using seedings, but using mulching. You know the mulch? You know, when you have trees, in the rural areas, in the country, away from the city, where there are trees. This mulch, like sawdust or any organic materials from wood, from any plants, they crush it, they put it like this as a mulch covering the soil. You can cover the soil also with wooden, some types of stones or wood, anything that will prevent the soil to run away or to storm water to have runoff with the soil away from site. We call this mulch. Mulch is a standard practice. We was using it to put around the trees to keep the moisture within the roots of the trees. If you remember, if you are not familiar with the mulch. So this is a way also we call mulching, depend on the location. Like what we see here, it's a small houses, villa, and the area is like tropical area where there is too much rain, so they put mulch. Okay. So every strategy subject to where your location, what are the constraints? Environmental people will help you much with this category. So we are here dealing with some pure environmental applications, insights. Environmentals and health and safety people here should know that. Also construction people know that about that also. There is no voice. Hello?
There is voice, Mr. Rashid.
لا لا no voice صح. Now have voice, right? Let me just reduce the. I think now is better. Uh, 1 second. Okay. Now is clear, I think. Hello? Okay. Let me know immediately if there is no voice. Let me know immediately, please. You can speak also. You can speak. Okay. Back again to the yes, yes, should be okay now. It should be very clear actually. Back again to our slides. Uh, Here we come to silt fencing. Silt fencing. What is silt fencing? Silt fencing is a strategy or a fence with a fabric that filter or remove the sediment, like what we see here in the front of us in the pictures. A silt fence. Silt fence. Okay. Um, Always exam includes some question about the what is silt fence and so on. Next is we call it sediment basin. Sediment basin or sediment trap. What is the difference? Sediment basin, sediment trap. Sediment basin or sediment trap is a way of uh, collecting the water in a basin or in a trap. Okay, like what we see here in the photo. The sediment basin is we make some excavation and we put here gravel. So the water can easily infiltrate within the trap, within the trap to the lower ground easily. Okay. And this is a sediment basin. Okay, sediment basin. But sometimes we call sediment trap. What is the difference? The difference only in here in the width. The basin might be wider and shallow, but the trap may be deeper and narrow. Okay, so this civil engineers work. See, we move from civil to environmental to health and safety. So everywhere the lead. This is what we can see here is the we call it the earth dikes or diversions. This tunnel, we call it earth dike, it's a diversion. We let the water, especially in tropical areas, we apply strategy earth dikes. Why? There is a lake there. There is maybe sediment basin. So the earth dike will take the huge amount of water directly to this area because I cannot manage it within my site. So I make a diversions. It's a amount of stabilized soil to divert the runoff through the desired location where I need water to be there. Okay. So location to where? To sediment trap or sediment basin. And I explained already the difference between sediment trap and sediment basin. Okay. That was the construction activity pollution prevention prerequisite. Now we move to site assessment. Any question for the previous part? Okay, let me ask then. If there is no question, I will ask. Engineer Ahmed, what is the difference between sediment basin and sediment trap? Engineer Ahmed Wahba, please, can you answer?
Sediment trap is narrow and more narrow, I think.
Okay, excellent. That's what I need only. It's narrow and deep. It's a
Yes, narrow
trap,
and deep.
like what you call it trap. But sediment basin,
Sure.
usually it is a wider, cover
And
a
shallow.
bigger area. Width and length is bigger. Usually sediment basin, we use it for evaporation. Why? The surface area is is bigger, so water will evaporate. Sediment trap we use to infiltrate, let the water go to the lower layer of the land. Okay, civil engineers are very aware, even better than us, about how to do sediment basins and trap. If we have civil engineer here, he will advise more details. But this only what we need in lead, what we need to do to know in lead AP. So be aware because I will ask anyone about what any credit after I finish. Site assessment. This is a prerequisite. The intent always is very important. You need to read it 10 times. Why? The intent, why you do that? Why you do that? What is the benefit of that? If you don't know why you do that, what are the benefits? Then there is no reason or you will forget it because you don't know what is the benefit. So first, always study the intent and make sure you understand it very well, very, very well. Okay. Now, the intent is to assess site conditions before design to evaluate sustainable option. I said before design, not before construction. So make sure you understand or you know the site conditions before you do any construction, because many options or many decisions you will make based on site conditions. Okay, you are not designing in the paper and the site, you don't know what are the constraints and what are the opportunities you can use on site to use in your design. So your design missing a lot. Your design missing is just a design in paper, but not realistic design, not economic design, not environmental design. You need to go to site and see what are the issues and start to find solution. This is a successful design. Since you are doing design, this is very important to you. Assess site condition before design to evaluate sustainable option. It's not about only EIA that you are doing environmental site assessment that is done after your design is done or in parallel. No, you need to go as a designer and see the site. Why and how? You see the topography. You need to remember this. Topography means ups and down of soil, of land. There is a mountain, there is a river, there is any water bodies, there is green areas. Topography, you need to see the topography, the high point or low points. And this will impact your also design. Maybe you have some design that can match the topography. It's not like you design in flat land, like a land with different levels. Of course, it's totally different. Either you have decision to make make it flat, or you have the decision to make a initiative or a design that will use the land topography. Depend also on your project type. Okay. Hydrology, the water bodies and so on. If we use it or you get rid of it or you change it or you reroute it, the climate. I'm designing a building in a hot climate or cold climate. It will impact, it has dramatic impact on my design. Vegetation, soil, the type of soil will impact, for example, the foundation. Decisions for concrete design, civil engineers work and so on, foundation. Human use. Is this site used before by anyone? Any health impact on humans? Any hazardous material within the site? So you need to remember all this. And when you go to site, you make a check and how you can manage this to be assets to you. Assets means something good. I will take advantage or favorable of it, like favorable climate condition. The climate is very good through all the years. 8 months a year is you can enjoy the nice air and so on. So why I don't open my windows, make a glazing, all the facades, especially the areas where there is nice air coming to me. But if it's very hot, then I need to close my facades. I need to make some heat treatment or sun exposure treatment to prevent the direct sun or heating my building from inside. All these need to be considered. So assets, okay, and liabilities. Liabilities, like as I said, you can find anything that treat or have impact on the people that will live in the site later after the building, or it will impact your design, the impact construction, design, construction, or operation process. Like all the structures, pollution source, steep slopes that will have steep, very high slope, so it will maybe it's dangerous. Extreme climate pattern, very hot, very cold. All this we call it liabilities or constraint. So when you design anything, of course, you have the assets or the things that you like and the constraints. The design is not a land length by width, and then you can start to make design. And from here neighbor. No, it's not like that, of course. So LEED will ask you to do what? Site assessment. What is the site assessment component, as we said? Any question here in this credit? Sorry, this prerequisite? Okay. The next is site development, protect or restore habitat. It is a credit, but very important credit. It is the center of the sustainable site category. The center of the sustainable site category. How it is the center? First of all, the name of this credit is very important. Site development, protect or restore. So we are developing site and we need to protect or restore. So the credit name is development of the site, and it has two options, protect or restore. See, now you almost finish the credit itself, the content, through the name of the title of the credit. You just need to know more detail about how to protect, how to restore. So in here, I ask you to memorize the name of this credit very well. As we used to do, we need to know the intent, why we need to protect and restore. When we develop, why we need to protect and restore. Back again. When we develop, why we need to protect and restore. So first, to conserve existing natural area. So I have green area. Can I conserve it? Yes, if possible. If not, then after finishing construction, you may be restoring these areas, green areas, making it landscape. You use it for materials and so on. To promote habitat and promote biodiversity, of course. This is the intent. How the strategies, always exam questions, come in the strategies. What is the strategies to inside development, to how to protect and restore habitat? Habitat means, what does it mean, habitat? Habitat means the natural, including the land and the living animals or any living or any ecosystem living within this land. This is a means of habitat. بيئة طبيعية in Arabic, if you for Arabic speak. So habitat, something include a living organism and non-living organism. So preserve means conserve, means protect. So be aware in the exam, if I say protect and restore, preserve, conserve, and so on, all these are the same meaning, protect, protect. So he say preserve. Preserve, here says protect. What? Green field or green area, the natural area during a development. If I cannot protect, what I will do? I will restore these areas that I have disturbed during construction to its original condition. And restore it doesn't mean just plantation. Maybe the land have been compacted, natural land, so I need to return or back the compaction to the natural compaction level for the soil. Okay, so restore previously developed sites. As we can see here, the red is building footprint or orange. This is hardscape here. And this, I think, is a parking, car parking or something. And vegetated area, native and adaptive plant, this area here. And here there is a grass field. So restore area, previously developed site. Okay. Open space with native and adaptive plant. So the restored area, which is the area of these green areas that I have, maybe make a storage or for material and so on. So I restore it to green areas. Except, of course, the area for development or footprint. What is footprint? The area for my buildings, okay, and the area for hardscape. This we call it footprint, development footprint, except development footprint because I built on it already. One last option where there are sites that are, the site area is the building area. I am building a tower skyscraper in a land 500 meter by 500 meter. I am building totally 500 meter, even the green area in the roof. There is no way to obtain any points in this credit. What I will do? No, there are still opportunity to obtain some points in this credit. It will be under financial support. You need to pay money in this case to any organization registered, recorded, international or local organization, but it should be recognized, of course. Okay. How much you will pay? You always pay per square meter around maybe $1 or 0.75 US dollars per square meters. This will take it in LEED AP exactly the number. The next credit is open space. Might be related to site development, protect and restore habitat, because in here, in this credit, you emphasize on open space, open area without development, with green area or with landscape and hardscape, this open space in LEED. So open space, and the previous one, protect and restore habitat, where we protect the green areas with its living ecosystems, right? So there is connection here, but let's connect both together, or let's first know what are the requirements of open space. Actually, both will help each other. When I have more open space, I have more green areas, I have more ecosystems, okay? So I have more habitat, so I have more protection, I have more restoration. So open space and the previous credits helping each other. To create exterior open space that encourage interaction with environment. Why open space we always do? It's not just green area not accessible, but it should be accessible. People can use it for social interaction and recreation. Just simply go and sit in the green area with the family, with the friends, or walk around. This for physical activity and so on. Here is the open space, which is an essential part of our designs. Strategies for open space. First, what is the definition of open space in LEED? Open space is vegetated or at least 50% pervious. What does it mean, 50% pervious? It means I have hardscape, I have areas with green and so on. So at least 50% is pervious, meaning areas that can naturally infiltrate the water. It doesn't mean it must be a green, maybe a gravel or any natural element for the hardscape and landscape, but at least 50% pervious. And again, pervious means water will absorb or water will run off. Pervious means water will be absorbed, will infiltrate. This is open space. From there, we can have pedestrian or oriented paving, recreational oriented paving, garden space, habitat, so many options the landscape engineer can do and employ whatever he can see best suits his design. Okay, so he has the full control, or he can do whatever he wants, but the maximum, we said 50% pervious in open space, is considered open space. The whole area considered open space. Yes, not a difficult thing. So the LEED required to maximize open space. In LEED APs, he will give you a percentage, let's say 25%, and then if you exceed this percent, you have achieved some point, you are achieving some points. Maximize open space, meaning reducing hardscape and increase the open space. Okay. Achieve the required area by increasing height, not width. The required area means the required areas to be built. You mean like build vertical and keep the site for landscape. This is what they mean here. Why? Because in site we are in the category called sustainable sites. So the intent here is to keep or preserve the land. Can you hear me clear, please? Okay, the intent here is to preserve the land. Okay, thank you. Cluster development together, make development together, maximize open space, reduce also stormwater. Why? because if I have open space, I have a land, a natural land area where I can manage the water runoff. No need to make drainage, water, pipes. No, I have green areas, right? Okay. So now we're moving to rainwater management. And again, the credit rainwater management is also connected to open space and site development, protect and restore habitat. See? Difficulty here in this site, you need to understand every credit and every credit requirement. Don't mix the requirement and in the same time connect the credits together. What this will benefit the other credits. We name it in LEED or call it synergies. Synergies like I do rainwater management here in this credit. So what is the benefit of doing rainwater management here, or how this will benefit other credits and other credits will benefit this? At the end, you have design tools. You are making design. You keep an eye on open space, protecting habitat, rainwater management. All you can work together and manage together through natural ways, which is using green areas, open space, and so on. Rainwater management. Of course, management means not allowing water to run off to the street, like what we see when the rain comes and we have not enough drainage, we'll find that the streets are full of water. And this also impacts the quality, because when the street water run in the street, it is taking all the pollution, and then after that, where it will go? To the land again, which meaning polluting the water life cycle, impacting the hydrology, the land and the hydrology. So improve water quality by replicating the natural hydrology and water balance is very important. Reducing runoff. How to reduce? We see this picture. Have we seen? We seen before? The start of the chapter. Reduce load on sewage treatment plant. Like no need to send water to be treated and so on. Why? Because when I use natural filtration, like this, even the grass is working as a filter to storm water that will run off. So it will not even run off, because maybe only 10% will run off. Okay, others will be used to planting, and it will be evapotranspiration, like evaporation from the plant, evaporation from the water, and so on. In case of here, like what you see, what is happening? All the water are running, more than 50%, of course, running here and then impacting all the developed area here. So we can see in Dubai how the infrastructure couldn't manage the water during the rainstorm, and how this impact even the social life, the life of the people. People lost many things, their cars, their assets, the water come inside the building. So we have to consider that it's essential. And you can see the impact after years. If development, the impact will appear. So reduce load in sewage treatment plant, try to implement by implementing natural or open space. Reduce erosion and sedimentation and eutrophication. What is eutrophication? I will show you now. Stormwater management. Reduce stormwater runoff, help maintain a natural aquifer recharge cycle, because it will not impact the natural aquifer. It is the rock where the water is accumulated here in the wells and so on. The groundwater. This is we call it eutrophication. When the stormwater it run with nutrients, like especially from the land, agriculture land, nitrate, phosphate, and so on. See, nitrate and phosphate. This, when it comes to water bodies, it will make this, what you can see here in this photo, this we call it eutrophication. It's fresh water bodies will occur naturally, but it can be a result of human activity, like cultural eutrophication from fertilizer now runoff and sewage discharge. So this is inorganic planting, inorganic plants. Okay, kind of plants, but they are not really alive. They are like here, like some organisms that take this shape. okay, in organic plants. This is eutrophication. Why it happened? Because of water runoff. Because of water runoff, it happened eutrophication. So now this is the impact. Storm water management. This is the credit name, storm water management. And we see the impacts. So how we prevent the impact, reduce stormwater runoff through strategies and implementation. And this where always the exam questions come. First of all, strategies where you have a space, a land available, especially in rural areas, not in the urban areas. We use in rural areas, it's logic to use non-structural, like what? We call it green infrastructure and low impact development. So what is green infrastructure? Something like this. If there is road here, I will make drain, and the drain will send water to a green area here where it will infiltrate. See, this is the road. If there is no road, there is a landscape. I put landscape, I put ground cover. I use this based on calculation that I have built this building and this area is enough to manage storm or rainwater without any infrastructure. We call it, or infrastructure, we call it green infrastructure, simple infrastructure to collect and infiltrate water. And we call this development type of development all a low impact development using rain gardens. See, rain garden. What is rain garden? Area that is planted, we call it rain garden because it will work as a rain garden from the perspective of storm water. We call it rain garden. A bioswale. What is a bioswale? Bioswale. Also area like this, and we put like diversions or kind of interlock where the water also can run and to some specific area. Penetration soil. This is the soil where infiltration very high. Water will be collected here. It will just run over this grass and collected here and infiltrate naturally. Call it penetration area or cell. Okay. Pervious paving. Even the paving here for the car is pervious, so it can even water infiltrate or run to the green area. All this we call it LID, guys. LID, low impact development. And GI, green infrastructure. Must have question in the exam about what is the concept or what is low impact development and green infrastructure. So low impact development and green infrastructure, we call it non-structural strategies. But in urban areas, we can apply some strategies that are structural. Like what? Like collect and hold and treat stormwater in cistern or a tank, I mean. This available or suitable for urban sites. So I still can apply green strategies or structures, but for the aim of managing rainwater, and in this case, we call it structural strategies. But non-structural strategies always promote natural infiltration, okay, which suited for open space and area with extended land, like rain garden, vegetated swales, reducing impervious area, meaning make it pervious, and so on. So low impact development and the green infrastructures, both can be done through non-structural and structural. Okay, always low impact development is simple development and focus on how to collect water in a natural way. Structural always in urban areas we will use, non-structure in where I have land and I can have open space and so on. Of course, the credit open space also will help me here because if I have open space, so I can manage rainwater through the green area within my open space. Also back to the credit side development, protect and restore habitat, you will find the same. Are you with me? Everything is fine? All good? Here we can see even if you make paving or concrete, it can be, see, the water will not stay, infiltrate easily. So material selection When you design a walkway, design it this way, segmented, nice, very comfortable, and so on. So still water can infiltrate. It's not totally concrete. Even the park area, you can find the ambulance or this car fire truck where it stand easily and steadily in the we call it pervious paving. Pervious paving. See, the paving is open grid. We call it open grid. It's open 50%. It's not totally closed paving. We call it open grid paving or pervious paving. Okay, remember this: open grid paving or pervious paving. See the car how it's standing. Okay. Rain garden, simply a green area where I just can have. It's a garden, but when we talk about water, we call it rain garden. Okay, so vegetated filter strips like this. See, when the water run here and come here and infiltrate here, we put here ditch or stream. Ditch means like stones like this. So in here under this ditch, it is a sediment trap maybe. See, so we all connect all together, but be careful. Connect but not mix the requirement. Every credit have its own requirement. So channel or vegetated swales. Can you see? Vegetated swales. This is a vegetated swale, what we can see in the photo. What is then bioswales? Bioswales is like this. See, we make it store or aggregate and we put it in this way. So the water will run here, 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 and infiltrate it and then go to a drainage or sediment trap or a drainage, going to pipe, going to tank or cistern to collect this water. Landscape element designed to remove silt and pollution from surface runoff water. They consist of swale drainage. Swale means this. This is a swale course. Swale drainage course. This path, call it swale drainage course. Gently sloped site, less than 6%. So every 100 meter, 6 meters. And filled with vegetation, compost or riprap. So we can make these bioswales filled by vegetation or compost or riprap اللي هو الستون دي. This is stone. These vegetated swales, because it's all vegetated. This is bioswales because it has other peri options. Okay. A green roof. A green roof is very important thing in stormwater management. Why? Because in green roofs have many benefits. One here and one will take next chapter and one will take next chapter and one will take next chapter. The first one benefits here, green roof can manage storm water. And the excess water can be collected in a tank or storage tank. Okay, green roofs. Of course, other than the storm water, reducing heat impact, reducing heat or heating the building roof. Okay, so reducing energy. It can be also green area, like if you remember the credit open space. If you don't have open space in your site, you can consider green roofs as open space. You can consider, my voice clear? You can consider the green roofs as open space. Okay. Something like this. And you put cistern here to collect extra water. Very nice design, comfortable. So you wish you are living here in a green area, green roof, and in front of you there is a water cistern. Even you can use this water here to flush toilets or something. Of course, you are not using this for washing, but use it for other uses like flushing toilets and so on. The next is phenomena happen, especially in urban areas. This credit, we call it heat island reduction. Heat island reduction. What is heat island reduction? Or what is the heat island first? So before we know how to reduce, what is the heat island? Heat island is the temperature gradient between the urban areas and rural or suburban residential areas. Why? Because of this development, of course. See, around 3 Celsius, 3 degree, it's 3 degree in something not, it's not good, of course. So we need to minimize this. This we call it heat island effect. Because of what? Because of developments. Again, see, we just finished the green roof. So when we develop, the development, what happened? This solid surface make heating up, absorb the heat of the sun, all this asphalt and so on. So we always need to increase the surface of the area as much as possible to make it green. The green roof, the green landscape will reduce the heat island effects. So vegetation through green roof and green landscape. What if vegetation is not available? You need to memorize these numbers, huh? Using SRI, solar reflectance index. So I paint the roof white or any material that is high reflection. What is reflection? There are two options of the sun heat. Either I absorb or reflect. If you are, for example, if you are wearing a white shirt and walking in the street, you are reflecting. If you are wearing black and walking in the sun, you feel the heat, the real heat. Yes? So SRI, we call it solar reflection index. And it's number from 0 to 100 or from 0 to 1. 0 to 1 or 0 to or 1 to 100, like a percentage. Okay. So flat roof should have SRI 82. We call it initial. What means initially? At the installation, because of course after years of installation it will be less. So measure it at installation to be 82. Flat roof 82. This number and flat roof you need to remember. After 3 years, not initial, it should be not less than 64. Any number of these you can use if you have the information of initial, if you have the information of after 3 years. Okay. Sloped roof 39 initial, 32 after 3 years. So this is, we call it initial. This is 3 years aged SRI. You know, everything is wearing out. When you buy a new t-shirt, after you wear it a couple of years, you cannot after that, خلاص. It will reduce the quality and so on. So it shouldn't be less than 32 after 3 years. Otherwise, this material is not good. Remember this. What again the name, the SRI means? Some people ask me, what is SRI? Solar Reflectance Index. Refer to ability of surface to reject the heat. So the higher the SRI, the more good. How? What is the ability to reject the heat? So for surface to have higher SRI, it should have higher emittance and reflectance or albedo. So SRI meaning they emit more, they reflect more. Reflection always we call it albedo. So if you see albedo in the exam, it's the same reflectance. SRI same is albedo. Reflectance is albedo. Reflectance always albedo. Equal albedo. So the sun radiation hit the roof is reflected or absorbed. Reflected, reflectance, or absorb. The percentage of reflection and absorb is the solar reflection index, solar reflective index. What if absorb? In absorb here, you will just have again emit after at night maybe. Do you know the asphalt? When you walk in the asphalt at night, very hot. How? Because it does not reflect, it absorb inside it, and after that heated, and at night become hot. And this is the issue here where we consume more energy. So if my building material absorb, meaning I will heat up inside, I will use more air condition. That's why we always say make cool roof in the market. See, in the market, for material suppliers, they call it cool roof. Cool roof. So the solar reflectance, the higher is better, like what you see, white coating and 2 coating and so on. See, higher from 0 to 1 as a percentage, or from 1 to 100. See, but gray and black, see, it's low. So they are not reflecting. So where it goes, of course, it is absorbed. Plus. Sometimes, of course, have also infrared emittance, but this is based on the property. So focus on the solar reflectance. The higher the SRI. The higher the solar reflectance, the higher the SRI. There is another thing we call emittance. So reflectance and emittance is high here. If emittance only is high, but reflectance is not high, it means this material will absorb and emit. But if solar reflectance and emittance are both high, it means this material will reflect. It's good. If you are confused in this, okay, forget about this infrared, because solar reflectance, the higher, the better. SRI. See? Okay. This for roof. For non-roof, hardscape also painted white, but it has a different numbers. For non-roof, use reflectance factor only without index. What is means reflectance factor? Percentage reflected. Very simple. Increase vegetated pervious surface. Use open grid paving. SR, see, we don't say in landscape or non-roof, SRI, we call say SR only. SR value of non-roof surface shall be 0.28. Okay? Or higher for 3 years aged SRI or 0.33 if aged data meaning initial 0.33 and after 3 years 0.28. Clear? You can use also shades or trees, shade of trees like this, or architectural elements like shades like this. Okay? Or you can use like solar panels covering the parking, so it gives shade and it give also so reduce the of course the solar panel have high reflectance, so the paving here will be cool. There is no heat up. There is no heating for the local climate here. Cool. Okay. To reduce also solar reflectance, what are the application? If you design, for example, a parking area, what you will do as a designer? Most of you are architect. What you will do? Would I put the parking in front of building with 100 hectares, or I put the parking under the building in the basement? Which is better for runoff, for storm water, for heat island? Any architect here? Most of you are architects, by the way. Okay. Next is light pollution reduction. We're almost done. The chapter we just need to finish before our break, 15 to 20 minutes. And then we'll take the practice and next chapter, water efficiency, because they are connected. Light pollution reduction. There is a light pollution. Yes. What is light pollution? Let's see how it looks like. See these lights. This light is giving light upwards and downwards. It light everywhere. Where we don't need this light at night, because we have some animals, some species that live at night, that rest at night. So you are disrupting the natural and the ecosystems. You are also closing the sky axis. Why? You cannot see the stars in the cities. When you go to the countryside or the rural areas, you can see the sky very clear. But in here, you cannot, because of what? Because of light pollution. Okay? And this light cause glare, like what you see. So you cannot see, really, you will not see anything. So it's excessive light, waste light, especially of also using more energy. So sites that produce glare, sites give light to other sites nearby, excessive street light with no cover. We call it cover the light here to give the light downwards, not to the sky. So all this will not increase the safety and so on, and it will not give any security, and it will consume energy because it's extra light. So what is uplight? Uplight like this, like I show you now the column, see it giving to the sky. When you are walking here, you will never see the lights, the skies. You walk in a street, of course. When you look to the sky, you will not see from your home window. But in here, see the light coming down only, walking or giving the light here in this area where people can walk safely. So I don't need all this excessive light. This we call it non-full cut-off light. Non-full cut-off means the lamp have no shield. You know the shield that's around the lamp, but here it has shield. It's inside, so it keeps the light down. This we call it full cut off. This one non-full cut off. Get it? So use always full cut off fixtures or shield like this, where the lamp inside, housed inside this shield. So it will give, it's a unit fixture, not just a lamp giving light everywhere. This we call it uplight. What is about trespass? Trespass, like what you see is this guy, and here the light is going not only here, but also to the neighbor. We call light trespass. So you need to always calculate the light, what will be the light at your fence, especially if the neighbor is not under your control. It's another entity or another management. So you don't need to disturb your neighbors. You need to comply with IES, Illuminating Engineering Society, IES standard, IDA, International Dark Sky Association. Remember this. Remember this standard, okay? Remember this standard very well. For interior lightings, you need to place it far from the window if you don't need light here, or close it at night, or use curtains at night. Why? Because you will not disturb the animals outdoors or the birds where you will see the light, they think it's morning. So this we call it also trespass from indoor to outdoor. Okay. Also use timers and occupancy sensors to switch off unnecessary light. Control light trespass through transparent surface by proper position selection of light fixtures here, far from the window, and closing transparent opening after a specified time. Like you can close this opening if you don't need it. There is no view or something. That's all about sustainable sites. So from stormwater management to heat island reduction, site assessment, construction, open space, rainwater, heat island, and lighting pollution. So we know there is light pollution. We know what is heat island, how to manage rainwater, what is open space definition, site development, how to protect and restore, and construction pollution prevention and site assessment. All this we have known now during our chapter, very interesting chapter. And I put for you also the in the resource a book have full of pictures and interesting. You read it only. I require you to study my slides, only study my slides very well, and go to the book, read it. You will pass the exam. Of course, you can also have some simulation exams. Many resources are available there. Then you can go to the exam and take your LEED GA certification as a first step in your green career to support your specialty as architect or whatever. I hope you I hope you have the benefit of this class. And let me see the prayer time before we take. I think already finished. So we'll go to break and prayer, and we'll come 12:45 for answering chapter questions and moving to the next chapter, water efficiency. Thank you.